Hello. In this video, we're going to learn how to find a trigonometric angle in radians when you're given a trigonometric ratio. Here we're being asked to find the angles corresponding to the following trigonometric ratios. We'll talk about what those words mean in a second, in radians rounded to the nearest hundredth. Don't forget to put your calculator in radian mode when you're working with radians. In this question, we're given the following. Cos x equals negative 0.1391. As a reminder, big X is our angle, and cosine of an angle gives us our trigonometric ratio. Right? For cosine, that was our x coordinate divided by our r value, our radius. So here we notice that cosine is a negative number. My cosine x is a negative number. So that means when I use my cast, I got to look for the quadrants where cosine is not positive. So in quadrant 4, for example, no, my angle x could not be there because cosine is positive. In quadrant 1, no, my angle is not there because all the ratios are positive there. In quadrant 2, yes, that works because only sine is negative there, so cosine's negative. In quadrant 3, yes, my angle could be there because only tangent's positive, so cosine's negative. So my quadrants that interest me are quadrant 2 and quadrant 3. I'm going to draw the two angles that x could be. So it could be here in the second quadrant, that's a possibility. It could be here in the third quadrant, that's the other possibility. In my calculator, I'm going to find the reference angle beta. Some people call that the related acute angle. Remember that that's always going to be between the terminal arm and your x-axis. So that's my reference angle for quad 2 and my reference angle in quad 3. In the calculator, my reference angle, which I'll use beta as a symbol for, I'm going to do cos minus 1 of, I'm going to take an absolute value here, 0.1391. So that means I'm going to enter a positive value in the calculator when I do this. 1391. And when I do the calculation, the calculator gives me 1.43 radians. So that means up here it's 1.43 rad, and down here it's 1.43 rad. We're not done yet, because we found the green angle and not the black angles. We were asked to find the black angles. So let's bring the reference angle into the correct quadrants. Quadrant 2, well, this line's 180 degrees. 180 degrees, or in other words, pi radians. Notice that my angle is less than pi radians. It's less than a semicircle. So what I'm going to do there is x equals pi minus my reference angle, 1.43 rad. And that's going to give me in my calculator 1.71 radians. Similarly, in quadrant 3, the angle that interests me is actually just above 180 degrees. Oops. So it's like 180 degrees and a little bit more. So that means I'm going to do pi plus my reference angle. 1.43. In my calculator, that gets me 4.57 radians. So in other words, to recap, when I need to find an angle, so when I need to find this angle, but I'm given a ratio, I have two possibilities for my angle. One possibility in one quadrant, another possibility in another quadrant. I got to use CAST to find them. Then my calculator gives me my reference angle, but then it's up to me to put the reference angle in the correct quadrant. Thank you for watching.